This is a router. Okay. Now this laptop is sending some data. And if you remember, we talked about the MTU size in our last class, right? Now let's say this laptop is sending you data and this connectivity, right? It has got some MTU data, MTU size of this interface and this interface. Let's say it is a 1500 byte and this data is sent to the router here. Now imagine this router has got the destination through this interface, but its MTU is only 500. Okay, this is router and this is your receiver over here. Only 1500 byte. Okay, now this router still need to send this data to the receiver here. So how will this router send this data to receiver? Here the transport, you have the MTU size is a 1500 byte. Here it's a 500 byte, but you still need to send data to receiver. So basically, as we have seen in that field, so we have got identification, flags, and fragment offset. Because this interface MTU size is going to be a 500 byte, it need to split this data into three parts, right? Now, this is going to be a 500 byte. This is going to be a 500 byte. This is going to be a 500 byte, right? It has been divided or it has been fragmented into three different segment or three different packet, right? Or let's say three different header. So whenever a receiver receives this, how can receiver confirm it belongs to the same data? I am receiving the same data. It's a part of a same data and it is coming in the fragmented way. How will receiver know that? Correct? Second thing, okay, second thing I'll come to it. But so receiver needs to know that this is the part of the same data. This 500 byte, 500 byte, 500 byte, what I'm receiving is part of same data. So what it happens now, in this fragmented piece, they will add a flag called more fragment. Okay, I'll just write MF. They will add a flag called more fragment, and it will also add the identity. Let's say I am going to add 123, 123, 123. So they are going to treat this as another different IP header, but it is not like a IP header format what we just discussed, because it will have a different identification number here, right? But because they are using the same identity 123, 123, 123, and flag called more fragment, more fragment, more fragment. Let's say this is your number one data that is started. This is your number two. This is your number three. That's how they put the uh, put the flag of more fragment, have an identity tag, and send it to receiver. Now, how would receiver again know that? These are not the duplicate data. So when I say the duplicate data, router is sending you the router is sending this data to you, right? Now, when you send it, this is, let's say, traveling through your internet. So when it is traveling through your internet, let's say some of the interface might have gone down during that period, and it is like rerouted to this way. Again, like it is connected here. This interface might have gone down during that period, and again it is rerouted this way. Even here, let's say if you have multiple paths, when you send your data, this interface went down, but another part is from here, so it may go through here, which means you may be sending this data into the different order. So you may not just deliver 1, 2, or 3 at the same time. So 2 can go first, 3 can go first, 1 can go first. And again, if you are receiving multiple data, how can you say that uh, it is not the duplicate ones, right? How are you going to maintain the order? So based on the more fragment bit that is turned on, it will identify that, okay, this is the part of the same data. So these are not the duplicate. I can see the more fragment bits turned on, and they also have an identity. But how I'm going to reorder. So whenever receiver receive it, like I said, it might have a it might receive a number 2 first, then 3 first, or 1 at the end, right? So that's where the fragment offset come into the picture. So basically, it starts with 0, which means my first data is beginning from here in the 0. Let's say this has a tag of 0, and this is a 500 byte, right? So whenever, let's say number 2 received on the receiver end first, it might have a fragment offset of 501. So why? Because our data is 500 byte, and it is telling how far is this number 2 is from my starting field. Like let's say if this is my starting, this is where the another like number 2 starts. So if you are 500 byte, so this is 501 byte away, right? Because you are starting with the 0. So which means whenever 2 is received, it may have a fragment offset of 501. And let's say these are the 3 data. So in the once this 0 is also received to this receiver, it will have a fragment offset of what? 0. So from which it can tell this is my first packet. And when the 3 arrived in the receiver side, they won't have this more fragment bit turned on. Okay, it won't have this more fragment bit turned on because it is the last packet. And it knows that it is the end of the packet, but it will have a fragment offset of, let's say, 1000, 500, 500, okay, 1001. And this more fragment won't be there, and but 1001 will be there, okay, in the fragment offset. This value will be 0, but here the value will be turned on. Let's say we keep it 1 or 1 more fragment bit 1, and the more fragment bit will be 0 over here. And the fragment offset will be something like this. And that's how the receiver is knowing that these 3 packets are coming from the same data. And because it has the MTU size of this 500 byte, it has created the fragment, and it has sent like that. So what we need to understand is, like, some application may not like about um, doing this fragmentation. So some application may not like this. So you can also forcefully turn on the flag called don't fragment bit on and off. That's something like configurable that you wanted to do. But suggestion is always have your MTU um, same and equal between your two ingress and egress interfaces. Let's say if your MTU size is like 1500, make sure you do the 1500 here as well. And there are, like, in the data center environment, we have something called jumbo frame, which can support the MTU up to the 9000 MTU. So these are the big MTU frame. Basically, we call them a giant frame as well. Okay, I will talk about this more in when we go into the layer two segment. I will talk about the frame over there, but basically you just understand that, so the MTU can be supported up to the 9000 as well. Okay, is this clear? Any question?
All good.
Okay, so uh, basically this